Hey guys, S2 here from Be a Python Dev, and in this video I'm going to show you guys how to reverse an array, aka a modified list, because Python doesn't actually support real arrays, they're fancy arrays. But anyways, to do this we're going to first need a little dummy toy array to play around with, and you can see this is our guy. And then we're going to have a function here, just a module way to call the logic that we're going to be writing. Since we're going to do two ways to reverse this, we'll have two different functions. We don't really need this. This is overkill, but for the sake of getting better at writing functions, we're going to go ahead and do it this way. So what we want is two pointers. We're going to have a left pointer, and this is going to equal 0. We're going to have a right pointer. It's going to equal the length of the array, minus 1. So this will allow us to look at the last slot of the array, store that in a temp variable, and then swap it with the first one, and keep doing it until the left pointer is greater than the right pointer. That way we don't need to worry about midpoints. For example, if we have an array of length 5, you're going to have that middle slot, and you don't really need to swap that. But in this case, we just have 2 is greater than, well, 3 is greater than 2, and then it'll just quit. So we don't have to do any fancy midpoint checking. And we just do while LP is less than right pointer, temp equals a LP, left equals, well actually, no, new left equals ARP. I'll show you a faster way to do this too. And then actually, no, we just want to just since we already have the thing, we don't need those other variables. We can just go ahead and swap it. So the right pointer value will now equal the temp. Oh my god, I don't know how to type right now. Alright, so this should do it, and now we just need to increment our pointers, as is common in these little algorithm challenges, especially when you have 2-pointer solutions. Increment the left, decrement the right, and that should be good to go. And we don't actually need to return this since Python operates on things in line. Yeah, I should just be able to show you what I mean by that. So we're going to do two ways. One is the not so good Pythonic way, because it does operate on things in place. Even the problem with that is if we do new array equals A, it'll still keep the same memory reference. I'll show you what I mean by that too. So we'll just show you reverse array A. And since we're using the name A in both places, we're going to go ahead and change this. This will just be our array. And then we'll reverse array on our array. Go ahead and save this. And then just run it. And that doesn't work because stuff. And it shows none. Why does it show none? That's actually kind of confusing. I thought it just it shouldn't show none. I guess the function actually returns none. So it's printing the function return instead of printing the array. So if I just call this function and then I print our array, that'll show the reversed array, even though we're not assigning anything. And that is because Python functions do things in place. So even if we do reverse array, response, we'll just do return array equals A, and then we will replace these to say return array, because why not? And then we will return the return array. So now we will print the return array, and we will print our array second. And I'm pretty sure they're both equal to the same thing. And they are, because this return A just equals A, and even though we're doing things on the return A, we are updating the A reference as well, which is a little tricky thing in Python that you want to avoid. And you can do that with like deep copy, I think. From deep copy import, maybe it's from copy import deep copy, and then A equals deep copy A. Maybe this will work, and I think this will actually keep two different array references. Okay, so you can see the returned array now is 321 here on the bottom, and the original reference array is still 123. This does use extra memory, but the memory is released when you go out of scope of reverse array. Well, actually it's still used here, and then you go out of scope of this, and then the memory should be garbage collected. But anyways, that is just for some knowledge on how Python stores variables across functions. But actually this function can be cleaned up. Let's go ahead and do this using some fancy Python inline declarations. So Python does let you declare multiple variables in the same array, or multiple variables in the same line. So we'll go ahead and take advantage of that. And Python also lets you assign multiple variables in the same line. Well, not even assign, like swap. So surprisingly this does work, and it's kind of handy. Kind of neat little trick. And again, since Python will just do that in by operating on the reference our array passed in instead of by copy, you know, we can just do this, and you see we're still printing 321. And just to show you that this is actually updated code, I'll go ahead and update our input array, and now you can see 4321 is reversed. That is one way to reverse an array, using an actual function and swapping variables with a two-pointer approach. And you can also just use the Python built-in. So you can just do, you know what, I don't want to do that. Actually, when I do that, does that show anything that I care about? No. Control Z, bring back all our logic, and then we'll also just show you print. That's not gonna work because it's just gonna reverse the reverse list, and it's not gonna look like it does anything. You know what? For the second demo, we're not even gonna do that. We're just gonna do print our array. Obviously this is easier. If you just remember, you can do : -1 and use what is this, like the Python splicing, inline splicing, to kind of do a little fancy reverse operation. And you can see we did reverse it down here. And just to show you that this is actually running our new code, we'll add the 5 in there like we did before, and you can see 5, 4, 3, 2, 1. So yep, you can reverse a list with a two-pointer approach. That's good for beefing up your algorithm skills, because this two-pointer approach is used in a lot of like trickier other problems. Or you can just use the Python splicing syntax to do that. So I hope you guys have learned some stuff about Python in this little video. Take care. Bye.